Hi, I am Akhilesh Kumar Srivastav. Uh, we will start with the programming of the graph from this lecture. This lecture will introduce you about how to take the inputs from the user for a graph and how to produce the output for the graph. Later in this series, we will learn about how to code for the BFS, the breadth first search, the depth first search, cycle detection, and many more algorithms related to the graphs. So let's start with the lecture. So there are several ways to represent a graph in the memory. One of them is the adjacency matrix. For example, if the graph is given like this, and if we have to represent this graph in the memory, then we can see that there are 5 vertices in the graph. Hence, the number of rows and the number of the columns for the representation through the adjacency matrix will be 5 each. It means we will have a matrix of size 5 cross 5. So this represents the connection from 0, this represents connection from 1, this represents connection from 2, 3, and this represents the connection from 4. Similarly, on the column side, we are representing the vertices. You can see that in the graph, 0 is connected with 1 and 4. So in this case, we will show the entry 0 to 1. It means in the 0 row, the 1 entry will be 1, and in the 0 row, 4 entry will be 1. The given graph is the undirected graph, so the vice versa is also true. It means there will be a connection from 4 to 0, and there will be the connection from 1 to 0 as well. So here what we said that we have seen the edge 0, 1. It means there will be connection from 1 to 0, and then similarly there will be connection from 0 to 1 and 1 to 0 both. Similarly, for the edge 0 to 4, there will be connection from 0 to 4 and 4 to 0 as well. Now we're looking for the another edge, the connections from 1. So the connection from 1, we have 1, 0, which has already been added. 1, 2, we will have to add this. So from 1 to 2, we will have to show the entry as 1. And similarly, from 2 to 1 also, we will have to show the entry as 1. Similarly, 1 to 4, there is a connection. So 1 to 4 will be shown as 1, and 4 to 1 will also be shown as 1. Similarly, we have 1 to 3 connection. So 1 to 3 connection will be shown as 1, and 3 to 1 connection will also be shown as 1. Now let's look at the connection from 2. So 2 to 1, we already have added the edge 2, 1. Let's look at the 2, 3. So for 2, 3 edge, there will be a connection from 2 to 3, and there will be connection from 3 to 2 as well. And then after this, we will have the edge 3, 4. So for 3 to 4, there is an edge, and similarly for 4 to 3, there is an edge. The rest of the entries, which has not been marked as 1, will actually be shown as 0. All the entries which have remained in the matrix will be shown as 0. So this is how we can represent the graph through the adjacency matrix. Now there is another method of representation of the graph, which is incidence matrix, wherein we represent the matrix, or we represent the graph like matrix, wherein each of the edge will be shown on the column side. For example, if I mark the edges as E1, E2, E3, E4, E5, E6, and E7, then we will have to make as many columns as the number of the edges. Like this. Now similarly, we will have the vertices represented on the row side. For even edge, you can see that the connection is from 0 to 1. Hence, the entry at 0 number row and 1 number row is shown as 1, and rest of the entries are shown as 0. For E2H, which is 04H, so the entry at 0 number row and the 4 number row will be shown as 1, and rest of the entries will be 0. Similarly, for 1 to 4 connection, which is the E3, so 1 and 4 entry will be 1, and rest of the entries will be 0. For E4H, which is 13H, so connection from 1 to 3, it means in the first row and the third row, it will be 1, and at the rest of the rows, it will be 0. For E5, which is 12H, so entry at 1 and 2 will be 1, and rest of the entries will be 0. For E6H, which is 23H, so the entry from 2 to 3 will be 1, and rest of the entries will be shown as 0. And then the E7H, which is 34H, the entry from 3 to 4 is shown as 1, and rest of the entries is shown as 0. So this is how we represent the incidence matrix. You can see that if we are representing the incidence matrix, in that case, the column-wise sum will be 2. If you take the sum of any other column here, that will be 2. And that is obvious also, because edge includes the 2 endpoints, and at those 2 endpoints, we are representing 1. So the sum of the column will be 2. Another way to represent the graph is the adjacency list. For example, for the given graph, we can represent the connection from 0. We can represent the connection from 1, then from 2, then from 3, then from 4, and then from, okay, fine. So there are 5 vertices only, so we will represent only 5 vertices. Now, the adjacency list can be represented in the linked list form. It can be represented as the array of vector, whatever choice you make to represent this. We are making a choice of representing it through the array of vectors. So we have several arrays, we have several vectors, and first we will represent the connection with 0. So you can see that there is an edge from 0 to 1, and there is an edge from 0 to 4. So we will represent it by 1, 4. It means in the first vector, we have the 2 entries, which is 1 and 4, which is representing the connection from vertex number 0. Next, we will represent the connection from vertex number 1. So 0 is the first connection, 2 is the next connection, 3 is the next connection, and 4 is the next connection from 1. Why so? Because 1, 0 there is an edge, 1, 4 there is an edge, 1, 2 there is an edge, and 1, 3 there is an edge. So 0, 2, 3, 4 are the entries of the second vector, which is representing the connection from vertex number 1. Then we are going to represent the connection from 2. So there are 2 connections from 2. One is 1 and the another one is 3, because we have 2, 1 edge and we have 2, 3 edge. Now from 3 to, if we have to represent the connection from 3, so we have 3 to 1, 3 to 2, and 3 to 4. Similarly, to represent the connection from 4, we have 4 to 0, 4 to 1, and 4 to 3. So this is how we represent the adjacency list. If you see, or if you look at the adjacency list in some other way, we can say that the number of entries in the adjacency list will be twice the number of edges in this case. For example, there are 14 entries in total. You can make a sum of this, and there are 7 edges. So this is representing the undirected graph. Had we, if we had the directed graph, in that case, the number of entries in the adjacency list would have been 7 only. It means the exactly equal to the number of edges in the graph. This is obvious also, because if we are representing the E1 edge, let's say 0, 4, so if we are making a connection from 0 to 4, so in the 0 vector, there will be entry of 4. And similarly, in the 4 vector, there will be entry of 0. So for single edge, there are 2 entries which has been made. Hence, there will be total twice entries in the adjacency list than as the number of edges. Now we will now represent the graph through a code. So let's try to write a simple code which will be representing the given graph we are going to write a C++ code for the same. So let's try to write a simple C code. Let's magnify it so that it is visible to you in a better way. So we are going to include IO stream then since we require the vector to represent a graph, so a vector and using a standard namespace. Now for representing the graph, we need array of vector. I do not know what will be the size of this ADJ list named vector. So I'm first declaring, or I'm first taking the input of the number of vertices from the user. So let's say V is representing the number of vertices, and then let's say E is representing the number of edges. So first I'm asking the user to input the number of vertices. So Cout, enter the number of vertices, which will be V, and then I'll ask the user to input the number of edges, which is E. V and E, both of these things will be the integer value. So we define V and E as the integer. And then this is the time for declaring the array of vector, and the number of vectors will be V. There will be one vector for each of the vertex and its connection. So we have to first take the input from the user, and the input will be the edges endpoints. So we have the E edges. So let's run a loop till E and ask the user to enter the endpoints of the graph. Or endpoint of the edge. And let's say the first edge is edge I. So there are two values that a user will input. One is the first endpoint, and the other one is the second endpoint. So let's take these things in the A and B. Let's declare this A and B as integer. After this, we will make the entry in the adjacency list A push back B, and since this is the undirected graph, we'll make the entry in B also, and we'll push the A entry there. I hope you must be understanding this, because if we have the edge AB, so in the A vector, the entry will be there for B, and in the B vector, there will be entry for A. We already have explained this earlier. So we now have the adjacency list with us. Now let's try to print this adjacency list. For printing the adjacency list, we're again starting a loop. So there will be exactly V edges, V vertices, sorry. And through this I, we will be entering in the adjacency list of each of the vertex. So for integer j is equal to 0 and j less than ADJ list I dot size, because I'm not sure about how many entries will be there in this vector. So I'll go with the size. And we're going to print the connection from I, all the connection from I. So the first connection will be ADJ list IJ. And once we'll print this, we'll just apply a comma so that we can differentiate between the other entry. And since this is the connection from I, let's apply, or let's print I, and then separated by the colon, such that we can represent all the connections from I here. And once all the connections from I is finished, we will apply a new line so that the other connections are shown in the new line. So I hope this code is clear to you. Let's try to analyze it further such that it does not contain any error. So we don't have any error in this. You can simply run it. So small correction is required here, that instead of Y++, we should apply J++. So we have made this change. Let's run this code. So let's try to make the entries here. For the number of vertices are 5, number of edges are 7. Edge 1 is 0, 4. Edge 2 is 0, 1. Edge 3 is 1 and 2. Edge 4 is 1 and 3. Edge 5 is 2 and 3. Edge 6 is 1 and 4. Edge 7 is 3 and 4. So here is the adjacency list of the graph. So I hope with this small code you have understood about how to represent the graph in the memory. In the next lecture, we will discuss about how to use this representation of the graph for finding out the breadth first search and the depth first search for the given graph. Thank you so much for watching this video.